Hey guys, this is the second video in chapter 2, the review on binary ionic compounds. Pretty short video, but kind of necessary. So if we remember from the last video, we had a couple things that we talked about, and one of them was the ionic charge. And if we look at remember the periodic table, we had a 1 plus for the column 1, a 2 plus for column 2, a 3 plus for column 3, a 3 minus for nitrogen's group, 2 minus, 1 minus, and that can get us a good number of ionic compounds. Now, I keep saying ionic quite a bit. Let's discuss what ionic means. An ionic compound is any compound where we have an actual transfer of electrons. Here's an example of that. We have an actual transfer of electrons, and the only thing keeping these guys together, so in this case we've got sodium and chloride. Sodium gives its electron to chloride, and the only thing keeping them together is the attraction that's naturally occurring between a positive and negative charge. Here's a better example of that. Here we've got an electron being transferred to this compound, and we have a negative anion and a positive cation. Okay, so that's what we mean when we say ionic compounds. Now these usually occur between metals and nonmetals. We'll see an exception in the next video, but that's what we're talking about: metals and nonmetals for the most part. Now, not all compounds between metals and nonmetals are ionic. We'll have to look at another pointer to see if they're ionic or not, and that comes a little bit later. Now, let's take a look at making a compound between two elements. Now, if we go back and look at the periodic table that we just wrote on, aluminum has a 3 plus charge, and chloride has a 1 minus charge. Now, what we want to do is we have to form a compound that's neutral. Now, the easiest way to do this is to do this little switcheroo thing where we make the charge, the number that's associated with the charge, the subscript for the other compound, or the other element in the compound. So Al would be 1, and we don't write 1, we just leave it like that, and Cl would be 3. So AlCl3 would be my compound. And if we look at it, aluminum has a 3 plus charge. Each chloride is a 1 minus, giving me a total of a 3 minus. A positive 3 and a negative 3 give me a 0, which is what we want. We want a neutral charge. Now, how do we name these things? Well, it's very easy. All you have to do is name the metal and then the non-metal ending in IDE. So this is aluminum, and then the non-metal ending in IDE. Much like this, aluminum chloride, the metal, then the non-metal ending in IDE. But we run into some problems if we leave it there. Here, we've got two compounds with copper, a transition metal. And transition metals are special because they can have more than one type of charge. Here we've got one type of charge for copper, and here we've got another. And if we were to use just the rules that we just talked about, we would have copper oxide. And on this side, we'd have copper oxide. And whenever you name anything, you have to make sure that you differentiate between two different things. And so we have to differentiate between the two different compounds. And the way we do that is Roman numerals. The Roman numeral is going to dictate the charge of the transition metal. How do we find out the charge of the transition metal? Well, we look at what it's bonded to. We know oxygen is a 2 minus, right? And in this case, we only have one copper atom bonded to it. So what does that copper have to be in order for this compound to be 0? Well, it has to be a 2 plus. A positive 2 and a negative 2 give us 0. So this is copper 2 oxide. If we look over here, this oxygen has a 2 minus charge still, but we've got 2 coppers to balance it out. And so what I usually do is say we've got a 2 minus, and we've got 2 coppers multiplied by some number to give us 0. And we can solve this pretty easily, right? Move the 2 minus over, and we get x is 1, right? And so this is copper 1 oxide. Now you don't have to do that. You can logically see that, you know, we'd need a 1 plus and a 1 plus to give us a 2 plus to cancel out that 2 minus. But that's one way of doing it. And so that's how we differentiate between compounds with transition metals. The final thing we have to talk about is making formulas from the names. So we have copper 2 oxide, copper 1 oxide. Now let's look at a couple of the names. We've got iron 2 phosphide and potassium sulfide. How do I find the formula from the name? Well, it's just like we did a second ago, where we did the little switcheroo thing. Here, we've got iron, and we're told the 2 here tells us the charge, 2 plus. And phosphide, that's phosphorus. And remember, phosphorus has a 3 minus. Now, once we have those written out, we can do this little switch thing, and we get Fe3P2. And if we look, we've got a 3 minus and a 3 minus from the 2 phosphorus atoms, giving me a 6 minus charge there. And then 2 pluses, running out of room, giving us a 6 plus. And so we've got a positive 6, a negative 6, and that gives me 0. Remember, compounds have to be neutral. So I know that my formula is correct. Always go back and check. Here we've got potassium sulfide. Potassium is K with a positive. Sulfide is S, 2 minus. So then we can do this little switcheroo thing again, and we get K2S. A really quick review of how to do compounds with just binary. Remember, binary is 2 atoms, or just 2 different elements. So binary ionic compounds. See you guys next time with polyatomic ions.